Hi everyone, in today's video we're going to look at flow problems. Let's firstly start with the concept directed graphs or digraphs. For a directed graph or a digraph, it records the directional information on networks using arrows on the edges. So the arrows shows the direction of from one vertex to the other. For example, the network below shows the roads around a city. If we use the vertices to represent the intersections, then the edges will represent the roads between the intersections. From your observation, you probably can tell that for some of the intersections, such as from intersection I to B, we actually only allow the traffic in one direction. But for some others, allow the traffic in both directions, such as I to F, B to E, same as C to D. Once we understand digraphs, we want to apply our understanding to understand minimum flow problems. One of the applications of direction graphs involves the transfer of flow of material from one point. For this starting point, we call it as the source, to another point called the sink. So we want to transfer the source through the network to the sink. Some applications could be, how do we understand the water flow flowing through the pipes? Traffic flowing along the roads. Then the water flows through pipes is only allowed in one direction. Then the weights of flow problem of directed graph are called capacities. The diagram below shows two pipes with different capacities are joined together. They connecting the source of water to the sink. So as you can see, for the first pipe, it has a smaller capacity that allows 25 liters of water per minute, then followed by a much larger capacity, which is 58 liters per minute. So you can imagine if we had only allowed 25 liters of water flow through the first pipe, then can only still have 25 liters of water flow into the second pipe. Okay? Therefore, the total capacity for these joint pipes gonna be 25 liters per minute. Now let's think about it. If we want to reverse the connection, we want to direct the water from the larger capacity into the smaller capacity pipe. There will be a bottleneck at the junction. So the large capacity pipe is delivering 58 liters per minute of water, but again, when the water flows into the smaller pipe, then it will still only allow 25 liters of water to pass. So in both of these situations, we can conclude that even though they have different ways to join the two pipes together, the capacity in both systems is restricted to a maximum of 25 liters per minute. So if we think about the situation, if we connect more pipes together, one after the other, we can calculate the overall capacity by looking at the smallest capacity pipe in that system. When we are looking at the concept of maximum flow, which means we are looking for the minimum capacity of the individual pipes. Right, let's put into practice. We want to calculate the maximum flow in this diagram. Now let's read the question together. In the diagram shown on the right, the vertices A, B, C, D, and E represent towns. The edges of the graph represent roads, and the weights of these edges are the maximum number of cars that can travel on the road each hour. The roads allow only one-way travel. The digraphs we have town A, B, C, D, E. We only allow one direction, which from A to E. And then for the capacity we have here, they represent the number of cars that allowed from one town to the other town. Question I. Find the maximum traffic flow from I to E through town C. So we want to calculate the capacity from I to E via C. Then there's only one way we can do it, which is from A to B to C to E. From A to B, we only allowed 300 cars travel from I to B. Even the capacity from B to C is 600, there will only be 300 cars. And same for C to E, 300. Therefore, for question A, the maximum traffic flow from I to E by C will be 300. Question B. Find the maximum traffic flow from I to E overall. We want to look at what are the possible ways we can have the traffic flow from I to E. Okay, we can go from I to B to C to E, or we can go from I to D, then E. As we already calculated for the first way, via B and C, we can have 300 cars as the maximum flow. Then let's have a look at the second route. If we go from I to D, then to E. I to D, yes, we can allow 500 cars, but from town D to E, only 150 cars are allowed. Therefore, the maximum flow will be 150 for the second route. Then we can say that the maximum flow will be 300 plus 150, which is 450 cars. Question C. A new road is being built to allow traffic from town D to town C. This road can carry 500 cars per hour. Part 1 of C. Add this road to the digraph. We want to build a road connect town D to C. So connect D to C, and it allowed 500 cars per hour. So we just label that the capacity as 500. So that's for part 1. Part 2, find the maximum traffic flow from I to E overall after this road is built. Part 2 of question C, we're looking at what is the maximum traffic flow from I to E after the new road is being built. Okay? So remember, from I to E we have two routes, I to E via BC or via D. After the new road is being built, it won't really impact the first route. Therefore, the maximum of route 1, the maximum capacity is still 300. But for route 2, after A to D, we can have the cars travel from the new road, which is D to C, because it allows maximum capacity 500. So D to C is still allow 500 cars, then C to E, the capacity is 800. So remember, when we're looking at the maximum flow, we actually working at the minimum capacity. So minimum capacity for the second route now is 500. Therefore, the overall maximum traffic flow from I to E gonna be 300 from route 1 plus 500 from route 2, which is 800 cars per hour. That is all I would like to cover for today. Thank you very much for watching.